in this tutorial, what we'll be doing is we'll be producing a drawing using various projection techniques that Axel discussed in detail during the lecture. So the intent is to use these techniques to produce a drawing that's visually pleasing, and that relates to your 2D composition and describes the forms that you created in 3D. So to start, what we'll be doing is we'll be looking at this object, which is basically my interpretation of this 2D composition. Just very briefly, the way the composition was created was we started out by replicating techniques used by Emil Ruder, who did a lot of work with typography. So he used projections, he played around with density of characters. Then we looked at the void relationships and then extracted additional information. And then we started folding these letters and offsetting them. And after that, basically connecting these letters using surfaces, using advanced surfacing techniques that Garrett showed you during the last webinar. From there, we start building a kind of a density, and then and finally, after that, we thicken the form, and it becomes a little bit more spatial. Now, this isn't ideal; it's probably not dense enough from what you're looking for, but I think it's moving in the right direction. So, just also very quickly, here are just some of the Emil Ruder techniques that were used to create some of these geometries. And then we extracted additional information. And then in terms of the overall graphical presentation, this is a project by Chumi, where the architectural solution was to encase these yellow volumes, which couldn't be touched, with a superstructure. So, but instead of drawing it like this, Chumi also played a lot around with projection, and he drew it like this, which superimposes the vertical structure from the roof, basically adding a layer of information, adding a kind of diagrammatic understanding to the drawing. So that's generally where we want to head. So in this composition, we want to identify various elements that you want to highlight or something that you want to read in the drawing. So, and then you want to try to carry that through as you develop it. So, oh, let me mute everybody again. Gotcha. No, I'm sorry. So I just muted everybody again. So you should be able to hear now. Yeah. So I advise everybody to have your headphones in. That way we don't get any interference with the mic. Yes, I just did. So now it's important to choose the axonometric projection technique that you'll be using. So I'll demonstrate these techniques on a simple cube, and we'll be using this construction plane, the C plane that you see at the origin, denoted by like the Rhino axes, as the projection plane onto which you will be projecting. So I encourage everybody to open up your geometry that you have from your assignment, because at the end of this tutorial, you'll be asked to turn this in on Blackboard. Whatever drawing that you create using a similar process. So in the meantime, I'll explain how you transform this cube into an axonometric projection. So a typical axonometric projection is your 30-60 axon, so we'll start with that. So I'll ask you to rotate your geometry. You'll rotate it by 30 degrees. And then that's basically the result in 3D. It's just a rotation. Then we'll go to the right viewport. So looking at it from this side, you can use the cell last command, select last, if you ever lose a selection, to bring it back. And then we will shear it, -45. So now you could see what occurred with the cube. In order to analyze it a little bit more effectively, we'll actually take the lines and we'll use the project to C-plane command. Or let me actually position it above. So you can see the way Rhino works. All of your projections, I mean, you can use various techniques, but generally what you do is you use the top view and the C-plane to generate all of the readings of your geometry. So this is a result of basically translating the points and the lines from this geometry. So you can see what's interesting is that if you measure the distances, these are each 3 inches. So in plan, you actually don't distort your drawing whatsoever. And the same goes for elevation. So this axonometry, what it does is it preserves the dimensions entirely. Like contrary in a perspectival projection, obviously these distances decrease. But in an axon, they stay true in this axon. So another type of axonometric projection you could do is you could do a 45-45. So same kind of thing. You rotate it 45 degrees in the top viewport, and then you shear it 45 in the right viewport. Now here's the reading that you get. So similarly, all of the dimensions are true, except now instead of having a bias towards a particular side, each one of these faces are represented equally. So is everybody following along? Does anybody have questions? So the commands are just rotate and shear. So now what we'll do is we'll start to explore some of the more advanced distortions that you can generate your drawings with. So for example, for this composition, if I create an axon from it, or did it upside down for once, but it's not very conducive to looking at this particular geometry in the 45, because you kind of lose these elements that bridge the composition together. So a 45-degree axon won't be conducive to this geometry. Instead, what we're going to do is we will be doing a kind of custom oblique, for lack of a better word. So we'll rotate this geometry 15 degrees counterclockwise to give it a slight bias. And then, let me verify that. And then we'll be shearing it by 30 degrees instead. So now you get this kind of reading of the geometry. The reason I like it is because you get to see these curved geometries continue throughout the composition. So for me, that's a reading that I want to maintain in my drawing. So I'm going to keep it at this. Yes. Yes, yes. So always you want to copy your geometry. For example, if you decide to try a different projection technique, it's good to have a copy of your geometry, whatever it is, so that you can try something different on it. So I also want to show you guys one example of the oblique that Axel showed, and then this is accomplished. You'll recognize it. So it's accomplished by maintaining the elevation, the face completely consistent without any rotations, and just projecting the rest of the geometry off to the side. So instead of using the right viewport, now we want to use the front viewport. And you shear it. So here let's do 30. Oh, actually, let's do 20. So this is that example that Axel was showing you with the gable house. So, does anybody recognize it? Kind of. Do you remember? Okay. But so what I'm trying to explain basically is using the shear and rotate command, you can achieve any kind of projection in Rhino as you're projecting onto the C-plane, top view. So I recommend everybody to just take your geometry right now and try applying one of these transformations to it. So again, you can shear in the top, right, or front viewports. Just play with it. Get something that you like. So now we'll start moving forward. I'm going to hide these. So now that you have this kind of geometry, the first step that we'll do in order to draw it is we'll just make 2D it. And on my slow computer, this takes a while, so I just have a copy right here. But basically, what we'll do is we'll take all of this geometry, and then you make 2D it. And then you have a bunch of options here. For example, you can group the output. I recommend that. That way, every object, the lines produced from it, are grouped. And then you can control the layers too. So after you produce the line work, I highly recommend cleaning it up a little bit. So for example, if you see artifacts like that, you can clean them up. For example, these lines, they're not necessary to understanding the geometry. They're just remnants of the process used to create the geometries. So these are the kinds of lines that you can subtract and whatnot. And obviously I'm not going to bore you with that, but just make sure that you have clean line work that you're satisfied with going forward. So after this, the next step is, since we have these lines, which is a construction that relates to one of Emil Reuter's techniques, which was then used to create the void forms in the 2D composition. We will actually maintain those. So what we'll do is we'll copy them over. To this line work. My apologies, there's a rogue surface in here that we want to get rid of. Oh. Did I not delete it? Okay. So now that we have this kind of overlay, what we'll do is we will consciously introduce a background. So just to give you an idea of where we're going with, we want to introduce something that reinforces the edges of this drawing. So on this background, we'll draw a rectangle, maybe something like that. And then what we'll do is we will actually use the curve boolean command. So that's curve boolean in one command to then start to color. So what we'll do is we'll color these two sides and also any kind of geometry that flies out of our artificial boundary that we created. And of course you need to do some graphical decision making to make sure that what you do is consistent with the look that you're trying to achieve. So now once you curve booleaned around your line work, you'll hit enter, and you can run the hatch command to then produce that kind of outline boundary, like there, for example. So then you can use select last to then select your hatch and then copy it to a given layer. So the next few steps add probably the most to this composition, and what we'll be doing is we'll be creating this fill, which is used to highlight a specific characteristic that you find in your composition. If it has to do with how you constructed your composition, that's much better. So it's kind of a notational technique to bring a certain element and give it more presence in the drawing. So we'll be using the extract surface command. And then what we're going to do is we're just going to click on this continuous plane that we use to that's probably one of the most defining characteristics of this composition. So we'll try to highlight this plane entirely. So everything it touches, everything it connects to. That's kind of how we'll be doing this. So then you can see that the plane wraps back around with that tongue. Then let's actually deselect a couple things here. But then instead of going down with this face, we want to actually highlight some geometry that's hidden in the composition, and then we want to bring it out. So what we'll do is we'll select this under layer. In the composition. Similarly, we're using this technique, as you've seen, to render all of the curved surfaces that right now, you know, in this mess of line work, you can't really see them too well. So we'll be selecting everything that's curved and that's connected to this plane. I'm not sure if we hit everything, but generally I think we're pretty close. So now that we basically highlighted the shapes that you want to give more visual presence to in your actual drawing, we'll run the extract surface command, and we'll translate them over, just using the move command or the gumball tool. So then you end up with these shapes. Now it's a question of how do you bring them back into your graphic. So one idea is we'll actually be using these shapes to project information onto, and that will help render the curvature a little bit more effectively. So one technique that you could do to do this is you could contour the shapes. So I can show you that. So we can select the base point. We could say every 1 inch. Actually, that seems not dense enough. So we'll do every ½ inch. So here's the contour command running, and what it does is it basically intersects your geometry with a bunch of planes and extracts those intersections, and creates this kind of reading. So this is the result of the contour command. However, it's a bit boring, so we're not going to use it. What we'll be doing instead is we'll take the existing information in your composition. So this could be any of the construction lines that you used, any kind of process that's documented. Mm-hmm. Okay, slow down a bit. Gotcha. Yes. Yeah. Well, it's random in the sense that I didn't use a specific coordinate system, but I'm looking for something graphically. So if you have a kind of foresight to what you're doing graphically, especially if you're playing around with a figure-ground relationship, playing and engaging the background, so like having a frame within a frame is graphically helpful sometimes. But yes. The long answer to that is yes, it's a random rectangle. It's compositional. It's not random, but yes. It's better, of course, if it's derivative of your process. So then you could see, like, for example, in this drawing, how certain elements break the background. So that's something similar that we're editing for, basically, in this process. So in that sense, it's a very specific characteristic that you want to develop, and it could be different things. It doesn't necessarily have to be a rectangle. So instead of using the contour command, what we'll do is we'll take these lines and we'll actually project them onto the geometry. So, and I'll try to explain how to do that. Go on group. I still need to delete that guy. Just to have a bit more density, I'm also going to tile this. Tiling, I wouldn't say is generally recommended, but in this case it's fine because it won't be super legible once these geometries are projected. So what we'll do is then we'll take these geometries and we'll actually project these geometries like this onto this onto these surfaces that we want to highlight in our drawing. So what we'll do is we'll go to the well, let's see this in 3D first. So we'll skew it a little bit like that, and then we'll go to the front viewport, and we'll just make sure that this, what we're using to project, covers the composition entirely. So like this it does. So then, in order to project this line work onto your surfaces, you select it, you run project, you select these elements, you run the project command. So then what you get is basically this set of projected geometries onto this surface. So this, besides being a kind of a decoration, it's also another layer which will help you read the curvilinear geometry. So as you can see, the curves actually follow the form of these surfaces. So now what we need to do if we want to bring it into a two-dimensional plane is you use the project to C-plane command. And then you can copy it over to your geometry. It's actually not copied exactly correctly. Let me fish for the insertion point here. So we'll match it up with the source geometry. So now it's now it looks like it is good to go. So now what we'll do is we'll just copy it over. I see. So this is your projected geometry, and now we have it here, and it's grouped, and we'll give it a different layer. So these will be white, and they will go above this this blue highlight that we're working on in the drawing. So what we'll do now is we'll generate the we'll generate this blue form. So you can take your geometry, you can make 2D, and you can so here's the make 2D. And also I think it helps notice that make 2D, what it does is it is just a project command. So it's directly related to descriptive geometry. All it does is it takes whatever geometry you have, it outlines it, and then it projects it onto the C-plane. So that's what the make 2D command does. And each one of those steps you can do it manually and tweak it. So here you have this kind of form. We'll again use the curve Boolean command to then develop the holes a little bit. So this right here looks fairly similar to what we want to represent. So, and you might notice that whenever you have a very complicated outline and you try and hatch it, hopefully this doesn't crash the computer entirely. But let me save it just in case. But it might not want to hatch for you. So a good technique to use to solve these kinds of issues is to actually rebuild the curves. So what we can do is we can set an outrageous point count. Ooh. Yeah, so something's wrong about these curves. Let's see. Let's ask Make2D to reproject them and regenerate them. Make2D is having lots of trouble. But now we can see what curves are causing the issue, so we can eliminate them. This is kind of an on-the-fly troubleshooting process that I didn't have to do the first time around. So you can see that that's a bad curve. That's a bad curve. So you can join the curves back together. And it's not closing correctly, but we'll just adjust the curve to close. So it's one open curve, and then you can use the close curve command to close it up there. So let's say if let's see if this plays a bit nicer with our hatch. So here's our hatch. So basically, after eliminating those problematic curves, you finally have the hatch that we're looking for. So what we'll do now is we'll superimpose the hatch in here, and we'll give it a blue color. So essentially that's how this drawing is set up in Rhino. So the key thing is to pay attention to how you layer information and organize your workflow. What we'll do in addition is one last thing is we'll generate this kind of shadow, which falls on the surfaces, and we won't actually construct the shadows by hand. We'll cheat a little bit, even though it's a descriptive geometries lecture. But what we'll do is we'll actually render this just in Rhino very quickly. But the key thing is that you have to change two parameters in your render settings. So in your render, instead of using a non-transparent background, you want to have a transparent background, and you want to turn off the ground plane. Also, we'll be using a good quality rendering setting. So then after you change those parameters, you just hit the render command. And of course, this is a very kind of basic render engine that Rhino ships with. Later in the course, we'll be using V-Ray for this. But in order to get shadow information that we're going to draw over later anyway, this is effective enough. So as you can see, it's starting to render. And then one thing that I forgot to mention is you might want to add a sun. So you could go to the sun command, and you turn your sun on. You can do manual control, and you set the sun however you like. So that will actually produce shadows that you can control a little bit more. So I won't render it again, but I'll show you the result. So this is the base render that you basically end up with. So with these elements, what we'll do now is we'll take this into Illustrator, and I'll show you how to color it in Illustrator and set line weights and things like that. So you select this, you export selected. With Illustrator, just make sure that whatever you're exporting is very close to the origin, or else it falls off the Illustrator artboard, and then you can't get it back. So we'll go here and we'll set it as exercise 1. And of course I'm using the proper naming convention. Which is always good for discipline. So then I launch the export that we just produced out of Illustrator. I'll try to free up some computer memory by closing Rhino. So here's our result. It's a little bit bigger than 24 by 24. But now what we'll do is we will bring it in, and we'll set it in the middle. So here on the reference point, if you know your composition is like 24 by 24, you could set 12. Make it a little bit smaller actually, so you can read some of the interesting elements. And then some of these layers, they're white, so you can't really see them too well, so you can go to the options for the layer. You can set your layer colors. So you can see that a little bit better. So I forget how we cropped this one. Maybe not so drastically. So from here, what we'll do is we'll just organize the order of the layers. So everything on the hatch outline black should have a fill. Oof, that's a problem. So let's see here. So this we get rid of. So that was just a rectangle that wasn't supposed to be here. So we set the registration fill. Now there's actually a difference between this registration fill and just black, because registration fill, when you print, it's actually composite black. That means on a CMYK printer you run all 4 inkjets instead of just the black jet, which gives you much richer black. So when you're working and when you want to print and you want to have like drawings that pop out of the wall, if you use a lot of blacks, just make sure that you use the registration for your fill and stroke, which is that crosshair symbol. So that's the purpose of that. So any of the reference lines, we'll set them to black registration, and we'll set them to maybe 0.5 line weight. So if you're working on a really large area, so like 24 by 24, probably the smallest line weight you want is 0.5. If you go any smaller, it starts to fall apart. And then you can set a dash, 5.3. And then these elements start to come in dashed. Also, I'm going to go over clipping masks in Illustrator. So we want to crop this whole thing to the artboard. So what we'll do is we'll draw a shape, move all your layers under that layer that you just drew the shape on. So basically what it is, you have your layer, and then you have a rectangle that you use as the cropping tool, and then you have all your other layers underneath. Then you use this button to select that object. You click on the layer, and you click here, make clipping mask. Then that clips, clips your drawing. So for these white lines, we want to also set a thickness that's appropriate. Let's say 1.5 white. You can change the character of the stroke here, so whether you want sharp corners, so sharp corners and 1.5 thickness. That'll give you nice sharp edges. The alternative is to have round corners, which doesn't really look, well, on thin lines it doesn't look too good. On thicker lines it looks much better. So for the line work, we'll use just 1 point black registration. So then we have this much information. You might say, well, it still doesn't look like this, and that's because we haven't brought in the shadow information. So what the shadow information will do is it'll help read some of the curvatures a little bit nicer. So even though that you can see basically how these curvatures form, just based on the projections that we did, which are really telling, especially if they're symbols, like in the human language that you recognize, like the letter D or the letter X, it's a known geometry, so projecting that onto a plane will tell your eyes how that plane is in 3 dimensions, so it'll have that implication. But what we'll do to the base rendering is first we'll open it in Photoshop. So and then once, sorry, give me a moment here as it loads. Bring up some more memory. So if you set your transparent background and you eliminated the ground plane, this is what you'll end up with. So you could do image trim. You could trim your composition. And that helps for sizing in Illustrator mainly later on. And then what we'll do is we will take the ambient occlusion rendering that we have here, and we will basically play around and decide which parts are going to be used for the shadows. So in this rendering, the blacks will be used for the shadows. So then we'll save this as a PSD file. And it's important when you save it to maintain a transparency. That's actually something I didn't go over. When you export a rendering, save it as a PNG, because PNG files, they have an alpha layer, that's a transparency layer. It gives you the ability to have a transparent background, which is pretty important if you want to layer things. So always use PNGs if you wish to have transparency. The Photoshop format PSD also supports transparency, and Photoshop and Illustrator talk pretty well to each other. So what you can do now is you can take your PSD file, drop it in here. Since you trimmed it, it should be a little bit more manageable to scale it. We'll send it to the back, lock everything. So let's see. And it doesn't need to be perfect because we're not just using the rendering anyway. So now that we have that shadow, the question is, how do you get it to become a pattern? So what you do is I recommend that you duplicate your stuff. So you can duplicate that layer. You can call it rendering trace. And now we'll just use Illustrator's automatic tracing functionality to trace it. So you go to Window and you'll go to Image Trace. And then you click Preview on here. And it actually starts tracing those shadows for you. So instead of just having a pixel kind of raster rendering in the back, you can start to control your shadows a lot more. So we'll be using only fills. We'll ignore the white. Ignore the white's pretty important. You can see here it starts generating some artifacts. So maybe we want to dial back on the corners, and we want to dial back on how tight it fits the paths. So let's relax it a little bit. Maybe not too much. Then it updates for you. So this way you get you get a bit of shadow information. And so after you have your tracing result, you take it and you can expand it. So now all this is, your shadow is just a trace of this. So that's what Illustrator did. It just traced your pixel information with vector to create this. Now what we'll do is we will go to swatches. We'll go to patterns, basic graphics, lines. You can start playing around with these. If you want to edit the color, you could go into edit or object, pattern, edit pattern. It'll give you these parameters. You can then change the color. But for these purposes, it's fine to just have it black. I prefer the black in this case. So this is what you end up with. You end up with a graphic that is created using projections that layers information and that highlights something specific about your compositions, which I recommend that you work on. But most importantly, it maintains a graphical consistency, and it explores the moments that you explored in your 2D compositions. So that's basically the jump from 2D to 3D through projections and highlighting information in your drawings. So I think that concludes the tutorial, and now I'll take questions.